Imagine being able to shoot a firearm without the deafening roar that comes with it. A suppressor, also known as a silencer, makes this possible. When it comes to firearms, safety is paramount. One of the most critical aspects of firearm safety is protecting your hearing. Prolonged exposure to the loud noises generated by firearms can lead to permanent hearing damage. That's where suppressors come in, devices designed to reduce the noise of a firearm, helping to preserve your hearing and prevent damage. But have you ever wondered how these devices are made? From the intricate machining to the precise assembly, the process of creating a suppressor is a fascinating blend of engineering and craftsmanship. In this video, we'll take you on a journey through the step-by-step process of how a suppressor is made, giving you a deeper appreciation for the technology and expertise that goes into creating these innovative devices. Hearing loss is a common problem among firearms enthusiasts and professionals. The loud noise generated by firearms can exceed 140 decibels, which is well above the threshold for potential hearing damage. Prolonged exposure to these high decibel levels can cause permanent damage to the hair cells in the ear, leading to noise-induced hearing loss, NIHL. Suppressors can reduce the noise level by 20, 30 decibels, making it safer for shooters to enjoy their hobby without risking permanent hearing damage. This reduction in noise level can also help reduce the risk of tinnitus, a condition characterized by ringing or other sounds in the ears. By using a suppressor, shooters can protect their hearing and enjoy a more comfortable shooting experience. When designing a suppressor, manufacturers consider several critical factors to ensure optimal performance and safety. These factors include the type of firearm the suppressor will be used with, as different firearms have unique characteristics that can affect suppressor performance. The desired level of noise reduction is also a key consideration, as it will influence the design of the internal baffles and chambers. The design process typically begins with computer-aided design, CAD, software, which allows manufacturers to create a detailed model of the suppressor. This model takes into account the internal baffles and chambers that will help to dissipate the gases and reduce the noise. The baffles are carefully designed to maximize their surface area and optimize their configuration, allowing them to effectively absorb and dissipate the energy of the gases. The chambers are also designed to work in conjunction with the baffles, providing a controlled environment for the gases to expand and cool. Through this meticulous design process, manufacturers can create a suppressor that not only meets but exceeds performance expectations, providing a safe and effective solution for shooters. When it comes to selecting materials for suppressors, manufacturers consider several key factors including the intended use, weight, durability, and corrosion resistance. Stainless steel is known for its exceptional durability and heat resistance. Stainless steel is a popular choice for suppressor construction. Grades like 17, 4pH, and 316L offer superior strength and corrosion resistance. Titanium is a premium material that offers a high strength-to-weight ratio, making it perfect for applications where weight is a concern. Grade 5 titanium, Ti6Al4V, is particularly popular for its excellent strength and corrosion resistance. Aluminum is a lightweight material often used in rimfire suppressors or limited-use centerfire applications. Aerospace-grade alloys like 7075 T6 are commonly used for aluminum suppressors. Inconel is a nickel-chromium superalloy that offers exceptional strength and heat resistance, making it suitable for extreme use scenarios and full auto applications. The choice of material ultimately depends on the specific requirements of the user, including the type of firearm, shooting conditions, and personal preferences. By understanding the characteristics and limitations of each material, manufacturers and users can make informed decisions to optimize suppressor performance and durability. With the design finalized and materials selected, the next step is machining. This involves using computer numerical control CNC machines to precision cut the suppressor's components, such as the body, baffles, and end caps. CNC machining offers several advantages, including high precision. CNC machines can achieve tolerances as low as 1/10,000th of an inch, ensuring that the suppressor's components fit together perfectly and function correctly. CNC machines are highly consistent and can easily produce identical parts with minimal variation, ensuring that each suppressor meets the same high standards. CNC machines can create complex geometries and shapes that would be difficult or impossible to produce using traditional machining methods. The machining process typically involves several steps, including turning, where the suppressor's body and other cylindrical components are turned on a lathe, to achieve the desired dimensions and surface finish. The baffles and other complex components are milled using a CNC milling machine to create the precise shapes and geometries required. Holes are then drilled for mounting threads, gas ports, and other features as needed. Finally, the components are finished using various techniques such as anodizing or coating to enhance their durability and corrosion resistance. Throughout the machining process, quality control measures are implemented to ensure that each component meets the required specifications and tolerances. This attention to detail is critical to ensuring that the suppressor functions correctly and safely. By leveraging the precision and consistency of CNC machining, manufacturers can produce high-quality suppressors that meet the demands of shooters and hunters. The baffles are a critical component of a suppressor, responsible for reducing the noise of the firearm. The baffles are designed to absorb and dissipate the energy of the gases exiting the barrel, thereby reducing the noise signature of the firearm. The baffle assembly process typically involves several steps, including baffle design, baffle stacking, alignment, and securing. The baffles are stacked together in a specific configuration to achieve the desired level of noise reduction. The baffles are carefully aligned within the suppressor body to ensure that they are properly positioned and secured. The baffles are secured within the suppressor body using a variety of methods, such as welding, brazing, or mechanical fastening. Once the components are machined and the baffles are assembled, the suppressor is ready for final assembly. This involves attaching the end caps, mounting the suppressor to a test firearm, and conducting a series of tests to ensure that it meets performance and safety standards. Suppressors are an essential tool for anyone who regularly uses firearms, whether for recreation or profession. By reducing the noise level of firearms, suppressors help to preserve hearing and prevent damage. As we've seen, the process of creating a suppressor involves careful design, precision machining, and meticulous assembly. By understanding how suppressors work and how they're made, we can appreciate the importance of hearing protection and the role that suppressors play in keeping us safe. If you have any questions or comments, please leave them below. Your input matters. Share your ideas for our next video in the comments and we'll recognize your contribution. Thanks for joining us on this exploration of the fascinating stories behind everyday things. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching. And if you want to learn more, click the next video right here.